We have to explain why the given function is discontinuous at the given point. We have x equals 5. We know that the function is continuous at the given point if and only if meets three conditions. So first we have to check if x equals 5 belongs to domain of our function. We have for x less than or equals 5 function 5 minus x. So x equals 5 belongs to domain of our function. Next condition, we have to check the limit. We have limit as x approaches 5 from the left side first. For x less than or equals 5, we have formula 5 minus x. So we have to calculate this limit. Because we have subtraction here, we can replace x by 5. So we have 5 minus 5. This is equal 0. Next, we have to check the limit as x approaches 5 from the right. From the right, for x greater than 5, we have this formula. So we have to put x squared minus 2x plus 1. This is equal. Again, because we have square here, multiplication, subtraction, addition, we can replace x's by 5. So we have 5 squared minus 2 times 5 plus 1. This is equal 25 minus 10 plus 1. This is equal 16. We see that the left and right limits are different. We have 0 and 16. That's why our function is discontinuous at the given point. So let's now draw the graph of our function. Because our function has two parts. First is linear function, so the graph will be straight line, and the second is quadratic function, so the graph will be parabola. We need two tables. First, we have function 5 minus x, and we have to choose x less than or equals 5. So let's use -1, 0, 1, and 5. So we have, first we will replace x by -1, so we have 5 minus -1. This is equal 6, because negative and negative give us positive. Now we have 5 minus 0, this is equal 5. 5 minus 1, this is equal 4. And 5 minus 5, this is equal 0. So we have 4 points, -1, 6, 0, 5, 1, 4, and 5, 0. Now we have to draw the table for the second part of our function. We have now x squared minus 2x plus 1, and we have to choose x greater than 5. Like before, we check how behave our function for x equals 5. So we have 5, 6, 7. We have here x squared minus 2x plus 1. We can rewrite this to x minus 1 squared. So now it will be very easy to calculate the value for our function. We have 5 minus 1 squared, this is equal 4 to second power is 16. Now we have 6 minus 1 squared, so we have 5 squared, this is 25. And now we have 7 minus 1 squared. This is equal 6 to 6 squared, so 36. So we have 3 points, 5, 16, 6, 25, and 7, 36. We have to draw xy plane. First we have to choose the unit very small because we have 25, 36. So we need very small unit. First point is -1, 6, 2, 3, 4, 5, 6. Next we have 0, 5, 1, 4, and 4, 5, 3, 4, 5, we have value 0. Like I said before, we have function 5 minus x. This is linear function. The graph is straight line, and because we have negative coefficient before x, our graph will decrease. And because for 5 minus x, we have domain x is less than or equals 5, so it means our graph going to infinity. And we have graph from negative infinity to 5. This part, this is for f of x equals 5 minus x, this part. Now we have to draw the second part. We have point 5, 16. For 5, we have value 16. This was 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. And we know that this point doesn't belong to graph of our function. That's why I draw the circle, because for the second part, x squared minus 2x plus 1, x must be greater than 5, not equal 5. So next point we have 625. Because this is quadratic function, so the graph will be parabola, we can just sketch this part, piece of parabola, this part going to positive infinity. This part we can write as f of x is equal x squared minus 2x plus 1. And we see that we cannot draw the graph of our function without removing the pen from the paper. We have gap between 0 and 16. So we see that for x equals 5, our function is discontinuous.